Hi, everyone. Good morning, good afternoon, and even good evening to all of you. Thank you for tuning in from wherever you may be in the world. Really excited to be representing STL Partners on today's session, which is being conducted in partnership with Vault Active Data and being supported by HiveMQ. And today we're going to be exploring how the surging spend on real-time automation can be captured, and specifically why Systems Integrators are the pivotal go-to-market partner. As you can see, we've got an action-packed session that I shall shortly kick off with a presentation on the best practices for solution providers that are looking to drive real-time automation. I'll be followed up by Dheeraj Ramella, Chief Product Officer at Vault, who will be introducing Vault with insights on latency and its increasing value. And then by Ravi, who will be introducing HiveMQ as the company's Director of Industry Solutions. We're then going to further explore the themes discussed in the presentations with the Q&A panel, which is when we'll call on you, the audience, and give you an opportunity to get involved and ask some questions. To make things as seamless as possible, I'm afraid we do have a few housekeeping rules in play for you to be aware of. So as you can see, you should all have a control panel on the right-hand side of your screen, which you can expand or hide using the orange button at the top, as shown on slide in arrow 1. There's also a question box in the control panel, and we encourage you to type any questions or comments that you may have throughout the webinar, which we will then go through in the Q&A discussion. And just to make you aware, we will only use your first name, so it's not a case of knowing which individuals have asked what. And also just a reminder that you are sadly locked in listen-only mode. You are muted. If you are facing any technical issues, please could you notify us by using the chat box. If sound is the issue, what we'd recommend is you adjust your volume settings locally, and if necessary, sign out and sign back in again. The final point to mention is that with the webinar's conclusion, we will send out both the slides and recording of today's session, and it's an opportunity for you to share that with your colleagues. So just before we formally begin, I'm going to swiftly introduce the team today, the presenters and panelists. So I'm Jack, a consultant at STL Partners, who is going to be both presenting and moderating today's Q&A panel. And then I'm chuffed to be joined by Dheeraj, who works with partners of Vault in designing enterprise solutions at a national scale. And then Ravi, a product marketing and management leader whose expertise spans several industries and technologies. And then last but not least, we also have Darius Singh, one of the directors from the consulting team at STL, who also heads up our enterprise practice. So STL recently conducted a survey with nearly 600 enterprises across North America, Europe, and India. And we were aiming to understand digital transformation roadmaps. Specifically, we were seeking to quantify the implementation of automation use cases, understand the demand for managed services, and also the partnership landscape for deploying automation solutions. As you can see, our respondents came from quite a range of company sizes. So we had individuals involved in automation in various capacities. About 60% of the respondents were decision makers, while the rest included those influencing the decisions. And then actually, interestingly, we had some individuals who were directly responsible for implementing the technologies themselves. Today's findings and recommendations, which apply to all solution providers, are further supported by an interview program that we conducted last year, where we spoke to over 30 experts in the edge IoT ecosystems. Before we dive into the specific findings from this research, let's provide a little bit of color and a little bit of context for those who are new to the topic or perhaps could use a quick refresher. Real-time automation involves the instant execution of tasks and processes within data environments, completely eliminating the need for human intervention. And we can break this down a little bit more in detail into the two core components, real-time decision-making, one element, and then intelligent automation, another. So if we kick off with real-time decision-making, this uses data analytics, machine learning, and AI algorithms to generate immediate insights from existing data within a specific environment. So an environment that's dealing with large data sets from multiple sources. This can be analyzed instantly as they are generated. And what it does is it enables informed decision-making. I guess just to bring this to life and put it into a bit of perspective in a manufacturing setting, say, real-time decision-making can instantly detect changes or anomalies in machine performance and efficiency and provide instant alerts on this. This is where instant intelligent automation comes in. So that's what actually acts on the insights that are generated by the real-time decision-making part to minimize downtime and improve performance and efficiency. It leverages AI and machine learning to execute the recommendations from real-time insights. Returning to our factory floor example, intelligent automation can respond to the real-time data on equipment health, make the adjustments, and that will in turn reduce machine breakdown. So a use case that I guess is more commonly referred to in the trade as predictive maintenance. STL's edge market forecast is based on 20 key edge use cases. Those requiring both low latency and Internet of Things technology fall into what we describe as the real-time automation sweet spot. We'll discuss a few of these use cases in the next couple of slides, but what's key to note here is that given the demand for advanced AI integrated technologies and IoT, which all requires extensive coordination, the real-time automation sweet spot represents a significant opportunity for solution providers, and it's an opportunity to enhance enterprise environments that require edge and IoT solutions. Our edge market forecast also shows the total revenue across the value chain, outputting a full set of results across 90 countries over the 2020 to 2030 period. And for each of the 20 use cases shown, what we've done is we've cut the data to look at the use cases that the real-time automation that applies to real-time automation to try and understand existing and expected revenues for each vertical. So if we take the manufacturing vertical, for instance, which of course has numerous use cases that require low latency compute and IoT, this is why the forecast identifies manufacturing as the prime candidate to have the highest revenue from real-time automation. And our survey findings sort of substantiate that by showing a high degree of maturity in automation strategies and adoption within the manufacturing sector. We also spoke to a couple of people in our interview program, so the Chief Operating Officer at North American Edge AI platform, and they said how manufacturing is by far and away the leading vertical for Edge AI solutions. Another important sector to highlight is transportation, which is expected to see a rapid increase in investment in the real-time automation use cases between now and 2030. These industries present a significant opportunity for solution providers to offer their support. And if we just step away from the specific verticals for a moment, the reason why we expect the market for real-time automation use cases to proliferate generally across all verticals in the next half decade is closely tied with the advent of new technologies. So real-time automation at scale is becoming increasingly viable, and that is thanks to advancements in edge computing, IoT, and AI, which mutually enhance each other's capabilities. So you've got edge computing provides that high performance processing, coordinating between the IoT devices and supporting scalable AI functions. And by enabling real-time data ingestion and analytics, edge computing facilitates timely decision making for latency critical IoT applications. For IoT, that obviously ensures that the devices coordinate with each other to achieve common goals. It provides real-time source data, which is then collected and processed at the edge. And then the data is then leveraged by AI for more accurate model training and inferencing. And AI is using the outputs from trained machine learning models to deliver automated, effective responses in data-rich environments. And we can explore how these technologies apply to a couple of use cases and how they allow for more agile processes within them. So to start off with autonomous mobile robots, again, sort of back on the factory floors, edge computing and IoT, they enable the AMRs to intelligently navigate around sites, avoid obstacles, and they start doing this by processing real-time data about the surroundings and AI supporting the decision-making in order to ultimately prevent collisions. And another one, I referred to predictive maintenance earlier, and this again does have advanced technology elements. So edge-enabled video analytics and IoT sensors, both of these in tandem are automatically detecting faults in real time, allowing for like sort of swift anomaly identification and essentially enabling an optimization of production and maintenance. Despite this recent advancement in technology and the applicability to use cases, enterprises are still facing technical challenges to their operations. So in our survey, we asked respondents to identify the top 3 challenges currently impacting their operations. And we feel the results, and specifically the top three highlighted on the slide, they validate what we've really been hearing in the industry for the last 2 or 3 years. No real surprises here. Security, reliability, and privacy, they are the major drivers in adopting new technology. And any new tech, it really has to address all of these challenges. For real-time automation, if we apply those three to real-time automation, to security, the most frequently cited, real-time automation addresses this by using synchronous data processing, which enables continuous operation and improves output quality and efficiency. Privacy was also highlighted as a significant challenge. Real-time automation supports this through secure data practices such as encryption and access control to protect sensitive information from breaches and ensure that regulatory compliance. If we then consider some of the other challenges in this list and think about it maybe in a bit more of a future-oriented mindset, we know that cost is always going to be an issue. Downtime, we hear about it a lot in manufacturing, but it's not necessarily a big issue in the implementation of new technology because the revenue margins gained by reducing downtime, they're pretty slim. So that leaves the bottom three. So data residency or data sovereignty, latency, and bandwidth, which we're starting to hear more about for the three of them. So if we just go through them one by one, data sovereignty or data residency is something we're starting to hear a lot of chatter about in telco town. As regulations sort of around data localization starts to tighten, enterprises are being forced to store and process data within specific boundaries. And this is going to be accelerated by companies adopting public cloud solutions and this decentralization of data centers. And ultimately, this all comes together to increase complexity, which forces enterprises to prioritize data governance strategies. So I'll come back to latency. I'll touch on that in a little bit more detail. So if we just skip to bandwidth, this is something that also must be in solution providers' considerations as AI inferencing and video applications continue to grow in complexity, but also scale. They will demand higher bandwidth to process and transmit vast amounts of data in real time. And then just coming back, so really wanted to emphasize and hammer home this point on latency. I don't want to steal too much of the thunder from Dheeraj, Ravi, and the panel discussion, but I did want to touch upon why latency will be such a significant challenge for enterprises in the future. And why it hasn't been as much as a requirement up until now. And that's because ultimately it's just not really needed to be. Applications in enterprise environments, they're often operating where immediate response times were less critical. You know, enterprise systems were designed for internal use where if tasks are delayed, it doesn't really have a significant impact on business operations or customer experience. However, with this sort of rise of industrial applications, we're seeing more complex systems, computer vision, and an increase in smart devices. And these numerous applications, they're all accessing data simultaneously, creating a bit of a scalability challenge. And to meet this scale, the data layer, it must operate with low latency, as data from various systems now involves more measurements and more telemetry. The use of AI, the use of machine learning is growing, and to automate processes and minimize human error, that these technologies are just coming more to the forefront. Digital twins, they're maturing. We're heading towards this future where they're interconnected through standardized APIs. There's also this push towards creating a single source of data known as a unified namespace. And for all of these advanced technologies, there's a requisite that the data layer must deliver more complex data at lower latency. The data needs to be consistent, it needs to be highly available, and it needs to be delivered without interruption. So for many of these time-sensitive applications, low latency is going to become a critical dependency. And therefore, it really is essential that latency is an important point or feature of solution providers as they're actively future-proofing their platforms and services. I guess latency also ties together with this increase in need for data residency. So when residency laws, they're pushing enterprises to store data in specific environments, specific regions, the physical distances between those places is going to become a problem, again, sort of realizing this need for latency. In our survey, we asked our enterprise respondents to prioritize the traits that they consider most important when choosing a partner and choosing a partner to deploy new technologies. STL has evaluated the capabilities of various partner types within the solution provider ecosystems based on these traits, and the order in which the respondents prioritize them has determined the weighting assigned to each in this scoring matrix. So, for example, being a well-known brand and a thought leader, that was the top priority within our survey. 49% of respondents selected this, and as a result, this trait was given a 20% weighting in our scoring matrix. In contrast, where on the right side, we've got the ability to integrate services into a single solution provider. That was selected the least, so therefore it's only got 5% weighting. We've scored all of the ecosystem players based on the knowledge that we've accumulated from our extensive interview program. And what's clear is that the results that different players have, they've got distinct strengths. So Systems Integrators, it's clear that they're offering the most well-rounded solutions. They score highest in 6 out of the 10 categories. SIs, they're obviously helping reduce integration complexities. They provide onboarding training, which helps overcome both technical and organizational challenges, which slows the adoption of real-time automation. They understand the unique needs, they understand the challenges, the regulations, specific verticals, and demonstrate tangible outcomes through successful implementations in similar industry settings. However, despite being the best position to lead the go-to-market strategy with enterprises, it's not a full house. Like, there is still room for SIs to require support from other ecosystem partners who develop the individual components of these solutions. Independent software vendors, ISVs, so talking about specialist data platform providers, application developers, they're another set of key players in this ecosystem. They can support the SIs in delivering comprehensive solutions to enterprises by providing the best-in-class capabilities. And if we expand on that a little bit more, the software development expertise that these ISVs have, it allows them to create high-performing solutions for individual components, which are then integrated by the SIs. So partnerships between the two sort of enables the SIs to deliver higher quality, more comprehensive solutions, and it enhances both customer satisfaction as well as new customer acquisition. If we then return to our scoring matrix, what's really interesting is that the ISVs excel in certain traits where SIs are relatively less advanced. So the ISVs are particularly strong in the areas like flexible pricing, adapting to changing requirements, the ability to move quickly. Collaboration between the two would elevate a joint proposition and ensure that this overall offering encompasses all the traits that enterprises are looking for. On the previous slide, I touched upon how enterprises are going to want to start future-proofing for other technical challenges that haven't been as important up until now. Select ISVs, they offer these capabilities. They've got data management platforms designed to address emerging problems. And these platforms make data immediately useful for time-sensitive applications. And we'll hear about that in a bit more detail in the upcoming presentations from Volt and IBM. Just before I hand over to Dheeraj, I wanted to leave you with the 3 recommendations that we have based on our findings. So these go out to solution providers delivering or looking to deliver real-time automation solutions. First, target the manufacturing and transport verticals, and do this because of their relative maturity. The manufacturing sector, it leads other verticals in edge computing investments, and it does have those mature use cases that stand to benefit the most from real-time automation. Meanwhile, transport is this rapidly emerging vertical. It's the fastest growing sector for edge investments, and real-time automation from solution providers can address the key challenges within these verticals, including security, reliability, and privacy. Secondly, solution providers should partner with complementary companies. So to enhance their own capabilities, it was clear from the matrix that no single provider excels in all of the domains that enterprises evaluate. So what's going to become important is this idea of specialization, but also collaboration within the ecosystem. SIs, clearly they should be the primary partners, but they will require support from other ecosystem players to deliver comprehensive best-in-class solutions. So for example, SIs made the point that they should collaborate with the ISVs for those best-in-breed components to improve the service quality and future-proof future challenges. And then just our third and final recommendation is around future-proofing. So just building on that a little bit more, the environments, they are evolving. bandwidth, latency, and data sovereignty, they're going to become increasingly critical. There's no real avoiding in this reality. So the development and incorporation of these capabilities into a solution provider's product portfolio, it's essential for future-proofing operations. Yeah. So thank you very much. I hope you found that thought-provoking. I'll now hand over to Dheeraj, who will give a little bit more insight specifically on latency and how Vault and HiveMQ fit into this.
All right. Hey, thanks, Jack. So I'm Dheeraj Jamala. I work for Vault Active Data in the capacity of a Chief Product Officer, and another responsibility that I've taken on is build out a partner ecosystem. The reason we say ecosystem is essentially, instead of in one-on-one partnership, is that to complete the bigger picture of a solution for any enterprise, there are a variety of technologies that need to come in. But there is a key player as well. You know, when you look at the end-to-end solution, the key player is actually the systems integrators who are putting all of these things together. And we want to use this opportunity to share what we are doing at our respective companies and how Vault and Hive are working together in the industrial automation space. So we look at the three key things that need to come together is real time. It's such a broad term. We'll touch upon what real time means for us, like when Hive and Vault are working together in one of the slides that's following up. And using that context for the incoming data and setting a context and making decisions. And that's the intelligent edge, right? So now you can call it AI, you can call it ML, but at the end of the day, when you look at it as in English terms, this is how I actually look at it. So let's dig deep. So can we go to the next slide, please? So Vault Active Data, we were founded in 2009 by Dr. Stonebreaker. He's a professor at MIT. He's invented other technologies such as Postgres and Ingress in the past. The point of the space of the business that he built Vault for is high performance, high scale, low latency, high consistency and accuracy in decision making. So that's the platform of Vault. So we went to market in 2012. We're a small company, so we try to focus on verticals, and we've been focusing quite significantly on the telco area, especially given that 5G, genesis and people needing to migrate and needing something that can actually process their data really, really quick. And one of the key areas in the telecom space in the move from 4G to 5G was data unification. So incidentally, it's the same challenge that the automation and manufacturing industries are going through right now, which is very, very serendipitous that we can bring that expertise from that vertical into the manufacturing space. So it works for us and hopefully the proponents of the industry as well. Can we go to the next slide, please? So we talked about real time, right? So now you have there are two things. There's storage of data and there is processing of the data, and both needed to get faster and faster. Like traditional databases were slow. Then the NoSQL databases came in, but they basically had to make a lot of compromises to become fast. Now, on the other hand, you look at the processing side, the ever-tightening belt of latency is very visible, right? Like so, batch processing was enough because you just collected the data and then you process it, but then it was not enough. So then the stream processing platforms came in, the things like Apache Spark or something like that, where 15 seconds or less, and now that was a breakthrough. And then the belt tightened even further, and now then the platforms like Apache Flink came in, where it's hundreds of milliseconds to a couple of seconds, like from 15 seconds. So it's even tighter. Now where we are is because of the extent of automation that's taking place, the data needs to be found within single-digit milliseconds, really. All of our customers uniformly are in single-digit milliseconds, other than two of them that are in the outliers that go up to 20 to 30 milliseconds, but extremely low latency, right? So we look at it as a unified real-time data processing platform. So you can come up with nomenclature, but at the end of the day, it's combining contextual transactional data and incoming streaming real-time data. You need to put both of these together to be able to make the best decision, because your decision cannot be just made on the streams of data, but it's not even just the windows, right? So it needs to be a larger context of what is the process. When you look at an industrial automation setting, OEE is an equipment efficiency, but real efficiency is at the process level. So you need to look at a larger context, and you can look at the larger context examples across the plane. But these decisions need to be made under 10 milliseconds to be able to automate effectively. Okay. Can we go to the next slide, please? Okay, so why under 10 milliseconds, right? So is it just a curious experiment? Is it just going to fail? Or no, there is actual metrics that of value that people have been able to extract from the 253% increase in offer acceptance rate, right? So that was an example where our customer went from 200 milliseconds response to 4 to 7 milliseconds response with Vault, and that has a material value. The decreasing losses, that's a credit card fraud prevention platform that one of our partners actually built. And by moving from 150 milliseconds to 300 milliseconds to 20 to 30 milliseconds, this is the outlier a little bit, just because for every credit card transaction authorization request, they run about 1,500 to 2,000 rules in a single shot, and that needs to happen in 30 milliseconds, and that enabled them to decrease fraudulent transaction completion by 83%. Now you can put a variety of skins on this kind of automation to say, okay, I'm going to do like a bot detection, I'm going to do intrusion prevention, I'm going to do video-based defect detection. You take any of these, right? So the faster you can do this, the better you are able to protect your systems from breaking down, or being able to prevent more damage happening, or even save lives in certain examples. Okay. Now this doesn't need to be too expensive. If you choose the right technology, you could do it very, very effectively. And especially when you're moving to the edge, this is going to like make a whole new sense in your economics and dynamics. Can we go to the next slide, please? Yeah, so when we look at real time, what is it that we're actually talking about, right? So, and the reason I'm actually putting the players before us and the players after us that we interact bidirectionally with is because we clearly understand that this is not all Vault, right? So there is an ecosystem of technologies that need to come together to finish this. And when you look at end-to-end visibility, end-to-end latency, it's not a single technology problem. It doesn't matter that we do it under 10 milliseconds. If we are placed in a data center that's 200 to 400 milliseconds away, then we have to eat that latency, right? So how do you actually do that? And it's basically be as close to the data source, move data as securely, as reliably, and yet at a very low latency like Hive does. And once that data is moved, be able to process it like Vault does. So this is, in fact, like one of the core values of Hive and Vault coming together, that like without losing or making any compromises, being able to address the end-to-end latency, right? So we look at real time, and it's the ability to ingest the data, store the data, aggregate some KPIs, and when those KPIs are deviating from what would be considered norm, and then that knowledge, what is norm, what is deviation, can come from machine learning, and incorporate that inferencing into your decisioning, and the outcome of the decision would drive what is the most appropriate action to take. It could be do nothing, and that's an action. Do nothing is an action, right? So it's finding the needle in a haystack. If you have to pick every hay to look to find the needle. So it's this whole activity is what we're doing under 10 milliseconds. It's not like oh, I'm able to store and retrieve the data in under 10 milliseconds, right? So that's a significant difference. And this is the unified real-time data processing platform concept. Do more than just one activity when you have the data. So that's what we actually strive to do. Okay. Can we go to the next one, please? So what are we doing with Hive? So this we saw this, the UNS concept has been there, and it is actually something that is heavily done by systems integrators at this point. And I'm thinking like most of the audience here are quite familiar with this term. If not, I'll be belligerent enough to like explain, I suppose. Like so, it's the ability to move the data from silos of various applications between IT and OT in a manufacturing space, bringing them together to be accessible at any given point as a single source of truth. So you're able to look at what is the current state of my enterprise in general, right? So Hive does a stellar job of giving this unified view of all of the data at any given point in time. Now, with that information, if you need to make decisions, you need the near past context, and that's where Vault actually comes into play, right? So by combining Hive and Vault, you are able to have a way of proactively pushing data and decisions. The key is that the extension to push data to Vault runs in Hive, so that proactivity is reducing the latency of event to decisions, and by us pushing the control signals back to Hive, we're able to reduce the latency from the decisions to action. So overall, being able to proactively act on data. Okay. Can we go to the next one, please? So this is one of our reference architectures, like, because Hive has actually built a lot of tooling around, fast movement of data, reliable, secure, and yet also like have a map of edge cloud continuum and how to move through this series. And so this is representative of some of the work that we're actually doing, wherein Vault relies on Hive for this, but the flow itself is the data comes into Vault, the decisions are made, control commands are going back all at the edge or site, and send only the relevant data up into the cloud, thus saving your bandwidth. The three bottom criteria that are not seen as considerations because they're not readily understandable as English kind of a thing, right? So what does latency do for you? Being insecure, or well, not insecure, like being not secure, is immediately reflecting on a visceral feeling. But like, okay, my latency is not that low, it's not immediately understandable or transferable. But when you really look at where everything is going, removing human errors is going to become a big thing to avoid downtime. So today, I've seen reports where it's like 29% of downtimes are because of human errors responding to critical events. I've seen up to like 44% or something like that, right? So now, how do you eliminate that automation? If you're automating, you need a low latency, orchestratable data flow and decisions and actions. And this is where this kind of a reference architecture comes into play, wherein the decisions are made at the edge, the intelligence is built to support those decisions in the cloud, and those machine learning models are transferred back to the individual edges to make continuously adaptive decision making and better and better decisions. Okay. So I'm going to actually give the reins back to Ravi, where he is going to explain how Hive works and what it does for this equation and what the value is. So over to Ravi, please.
Thank you, Dheeraj. I appreciate it.
Indeed.
Hello, everyone. Good morning, good afternoon. Ravi Subramanian, thank you for the intro. And I think, Dheeraj, you covered a lot of great stuff already in your deck. I want to make sure that, oh, there you go. I have to share my webcam. That way I can come on. There you go. That's the guy that has been talking. Thank you. If you can proceed to the next slide, I'm just going to talk and focus on the aspects that Dheeraj didn't cover so that we can make sure that we give enough time for the panel discussion. So HiveMQ is the most trusted MQTT platform in the market. We were founded in 2012, and we are kind of like currently a Series A company. We got 50 million euros, and we have like enterprise customers across the globe in connected cars, in manufacturing, a lot of the areas that were covered in this presentation and in the survey as well. So if you can go to the next slide. Yeah. So why HiveMQ and why HiveMQ Plus active, right? So we are all about kind of like providing that reliable communication. We talked a lot about latency, right? That's one of the benchmarks of MQTT and what we do, because MQTT is all about ensuring that data is published when it's needed, when connectivity is available in low bandwidth situations, in small chunks, small packets. That way you can ensure that it's real time, it's low latency, and it is completely edge to cloud driven, if you will, right? So it's all outbound connectivity. So it's pretty good, robust from that perspective. But HiveMQ on top of that has added reliability, security, scalability to it. And these are some of the things that were mentioned in the survey, as well as things that are big concerns. So those are the areas that HiveMQ helps address while moving data and ensuring that we work with our partners to provide that ecosystem for manufacturing and other key use cases that we touched upon today. Next slide. Yeah. So again, that's all about like the main thing is it's connectivity. So on the left side, you have connectivity to the different assets that you might have on the field. Maybe you have like an oil well. It's sitting in the middle of nowhere. You might have an intelligent traffic light that needs to connectivity, a connected car. You might have a sensor data point, a moving vehicle, if you will, or a machine that is sitting in a factory, and all that is putting out data in a certain format, if you will, right? So we have something called the HiveMQ Edge, which is sitting on the edge. It's like a low footprint software that can convert some of this into like the MQTT format, which is very efficient, and then that helps integrate with IT systems, integrate with Active, for example, and then be able to communicate that, create that unified namespace, and ensure that all of the data, business data, is contextualized, is there in one location, so you can then use that for your advanced use case like AI, ML, and things like that. And then ensure that you have enough visibility and management tool to make sure that making sure that the data flows properly, and if it doesn't flow properly, you're able to see what is happening, if you will. Next slide. Yeah, so this is kind of like our overall platform. So you can see on the left side the various devices, and the way we can bring the data into our platform is through an MQTT client, which is basically like libraries that we provide that anybody can integrate. Or we have a package solution called the Edge, which has the ability to convert the data from the various formats into MQTT. We can add what we call the UNS alias. Unified namespace is just a term. It's a framework for ensuring that you have all of your business data in one location that's already contextualized, normalized, and available for your business use. All your alarms and alerts and all the real-time information that you need to make sure that your business is running properly can be seen in one location, and the data is already in the right format for you to be able to do all of the things that you need to do. And we also provide what we call extensions, which are SDKs off of our application for key use cases like streaming, databases, ensuring that like all of these different systems gets the IoT data. For example, Kafka, or as was mentioned, the Active gets data from our platform to be able to do what it's doing from a real-time analytics perspective, to ensure that your data is like completely, the latency of the data is completely reduced. The other thing that we do is ensuring that the data is high quality, because we truly believe that it's garbage in, garbage out. So if you're getting bad data, for example, or if you're getting data that is not necessary for you or not in the right format, and you send that to the cloud for real-time analytics, it's no good. So making sure that you have policies that can govern the data, put the data in the right format, consolidate the data between all of your different systems, ensuring that you have right definitions of those data, the data is transformed and brought into the right format, if you will, that makes sense for you, so that it then becomes like ready for you to be able to do what you need to do with that data. That's what we do. And our software can be self-managed, meaning like customers can buy our software and load it themselves on virtual machines or on the cloud, or fully managed. We have a fully managed solution that is on the cloud, that is available either on AWS, Azure, or Google as well. So, and the key thing that we focus on again is high reliability. Like for example, reliability is built into MQTT through all the quality of service levels that MQTT provides. On top of that, we also to high availability, making sure that if you have any downtimes for whatever reason, you're able to recover from it quickly. And from a scalability perspective, if you have millions of devices trying to connect at the same time, ensuring that the platform can support that. And maybe that all those connections are not needed at the same time, but the ability to scale vertically or horizontally based on the needs, that's what we do. And of course, we do all that while providing a highly secure and a highly private platform to make sure that you comply with all the privacy laws, either the SOC 2 compliance, SOC 1 compliance, or GDPR compliance for Europe and things like that. Next slide. Yeah, so this is just like showing the unified namespace and how you can bring the data from the different levels of your enterprise. Like you might have the edge where you might have certain data, but you might have many edges depending on, like if you're in a factory environment, you might have like different locations in the factory where you need to consolidate the data. The goal is like how you can do it at an area level, line level, site level, and then the enterprise, where really the unified namespace within your enterprise is going to be residing, that has the data across all of your enterprise and across like various systems within your enterprise. And that can then be used for any visualization purposes or analytics purposes or doing like streaming analytics and things like that. I believe that is the last slide.
Yep, that's right. Well, yeah, thank you both, Dheeraj, Ravi, for those introductions and insights. Hopefully they've given our audience a bit of food for thought as we move on to our Q&A section of the webinar. So just as a reminder to the audience, please continue to submit your questions by using the GoToWebinar control panel on the right of your screen. But I guess just to kick things off, in my presentation, I showed this matrix which suggested that SIs were the best position to take the real-time automation market by storm. Dheeraj, what do you feel SIs need to do in order to stay up to date with the right solutions that are needed to continue to solve evolving customer problems?
I think he's muted.
So, can you guys hear me?
All right. Yep.
All right, yeah. So it's a really interesting question because a lot of the times the shortcut is to go look at a magic quadrant or some technology wave or something like that and say like, okay, who are the leaders in that space? While that actually gives you a certain level of credibility, what it doesn't actually give you an exposure to is how easy is it to work with them? How integrable is their technology within an ecosystem? So what we're wanting to do is solve the problem for the SIs that are actually talking to us, right? So instead of saying like, hey, we do this, now go find other players, instead of that, we're saying, okay, let's form a community of ISVs that could actually do everything in that larger picture together and be able to give that total picture exposure to the SIs, right? So I'm not saying like, oh, come talk to me. Like that's the answer. That's not the answer for SIs, obviously. But what you really want to do is keep your eyes open to see up and coming technologies, not just look at the legacy dinosaurs. Like just because they're behemoths doesn't mean that they're adaptable for the future. So maybe they are, but just keep your eyes open for up and coming players as well, right? So just a piece of advice, I suppose. Ravi, any thoughts on that?
Yeah, absolutely. I think you captured everything, right? So I think a system integrator is absolutely important for specific industries, especially like manufacturing, where it's very, very complicated, right? Of course, we Volt and HiveMQ provide a lot of great solutions, but we are a part of a larger puzzle here, right? So we need a system integrator with that knowledge of how a HiveMQ and a Volt active data can come together along with, say, a sensor or like hardware or like a database or like cloud solution, and how all these things come together. So having that end-to-end expertise, keeping yourself like cutting edge, making sure that you're on top of technology, while at the same time understanding the customer use cases. Because often what happens is like, yeah, we can do this, we've done this before, and you just start doing stuff without even understanding exactly what the customer wants. Yeah. Right? Just having that like touch point and making sure that you kind of like bring in the rest of the team, right? Just not doing it in isolation. Sometimes like an SI needs to work with a VAR, like you mentioned, Jack, or with the other people in this ecosystem to make sure that at the end of the day, the customer gets what they want.
Great. No, that's great. It's two really interesting perspectives there, sort of.
Yeah.
Darius, I know that we've not heard from you yet today. Keen to sort of bring you into the discussion and sort of considering maybe from the customer side, what are the factors that the customers should be considering, the end enterprises, while selecting the right systems integrator to support them with their digital transformation?
Yeah, okay, that's an interesting question. I mean, if I speak a little bit first about some of the research that we've done in that space, both as part of this program, but also wider, one of the first things that comes up when you speak to enterprises about picking an SI is an SI that knows them, knows their business, and knows the vertical. So again, I think adding to what Dheeraj said as well, having that customer-centric approach, having a vertical expert approach and being aligned to their proposition and their needs and their challenges is probably going to be the one major factor. I think the next thing that often gets brought up is, of course, the actual technical suite. How good is that SI going to be at integrating across all of these complex different technologies? Because at the end of the day, for the enterprise, the systems integrator helps simplify. That's really what they're there to do across all of these different technology areas and helping them find a solution that really works and managing some of that for that enterprise. So I think that would be number two, is finding an SI that you feel like may meet that technical criteria to simplify. And I think the third thing that I would raise, which ties in more of this, taking more of an open ecosystem approach, I guess, is finding systems integrators that aren't super closed and don't want to just try and lock you into their integration capabilities. And we've definitely had some enterprises talk about working with a big global SI that just kind of wants to sell them a hammer when really what they need is a nail kind of thing, or it's that notion of overselling or saying, well, we've got this massive platform with all of this analytics and it can do all this and that. And it's like, well, actually, I only need a fraction of that, and I don't need all of the extra bells and whistles. So that would be another factor that I think would be important for an SI proposition, is making sure that it's targeted at the needs of that enterprise, rather than just saying, well, I've got this full suite, let's try and monetize that.
Mm-hmm.
Great. Dheeraj, Ravi, anything to add on that?
I'll take a first stab. It flows both ways, right? So while SIs should not look to pressure the customers into overconsumption, the customers also should have their eyes open for recommendations and about how to future-proof, right? So a lot of the times customers will be thinking about a point problem because that's what actually hurts, and they want to fix what hurts, but that has a root cause, right? So it's, if you really look at the root cause, it's probably because you're carrying some of the tech debt or entrepreneurial or enterprise debt that you're actually carrying that's timing you from going to the next phase of your growth. So there's a German word for this. I think I've shared this with you guys at STL in the past, like Einstellung effect, right? So it's like installed thinking. So you're trained to look at symptoms and respond in a certain manner, like it's the Pavlov's dog kind of a thing. So, but you need to break open that mold and say, like, okay, let's actually think differently. So the SIs can play a significant role because they're seeing what's happening across an ecosystem of customers. So I think it's a mutually respectful and responsible journey. Hopefully one is not trying to take advantage of the other, and the journey is together to go into the future. So. Right.
Very, very well said. The only thing I would add to it is, like, a good SI always looks into the future, right? Yes, while you don't want to oversell the customer, but at the same time, you don't want to undersell, right? Often what we see is like, oh, this is the cheapest solution. There's a lot of pressure from the customer to deliver within a certain budget, and you try to do something, only to realize later that, oh, you know what, the requirements have changed. The level of scalability, reliability that I need, right? The level of real-time data that I need, the number of servers that I need is a lot more than what I envisioned. Now the architecture needs to be changed. The vendors that I've chosen cannot scale up to that level. That needs to be changed. So that's kind of like doing the service, right? Yes, of course, you cannot look at the future and completely be sure of how it's going to pan out, but a good SI is able to kind of like predict as closely as possible on what the right architecture is and put that in place from day one.
Absolutely.
Yeah.
We do have a question from a member of our audience, and that's around actually managed service providers. I know the purpose of this session is mainly around SIs, but is there a place to play for the MSPs within this space? Are they arguably more efficient than the systems integrators in delivering some of these solutions? Does anyone have any thoughts on that?
I'm still thinking like, the managed service provider is the operation side, like at least in my myopic view, I suppose, like, I'll qualify it as myopic. An SI brings in the ability to be creative and be more artistic about where they take the customer, right? So an MSP is very formulaic, that being able to bring things together and make sure that they're serviced properly, they're operating properly. That's how I'm actually understanding the roles and differences between MSP and SI. So SI brings an intellectual component to it from their exposure and experience at various other customers.
Right.
What worked, what failed, that wisdom is irreplaceable, right? So that's the way I'm actually looking at the value. Perhaps one of the audience members could actually say how they differentiate.
Yeah, I guess just to add on that, I feel like the managed service provider, because they are a bit more operational, they see a lot of the day-to-day of the customer. So at day one or day zero, maybe it's not as innovative. It's maybe not as, it's a different role, as you say, but come to day 365, that MSP has a lot of knowledge about that customer and is a really strong channel for the rest of the ecosystem to actually start to think, well, what other products and services does this enterprise business really need, and how will it fit into the operations of the MSP? So I completely agree, Dheeraj. I think on day zero, they maybe have a slightly different role, but become very important when it comes to a year down the line.
Yeah. And there is definitely a role for both SIs and MSPs, right? I mean, like you said, Darius, they do the day-to-day, and SIs are more like more future-looking and looking at the overall big picture. So maybe there's a combination there that could work.
Yeah, the SIs could actually bring you to day zero, I guess, and then from day zero, MSPs take over. So that's
there you go.
There you go.
Yeah, love that.
And then we've got another question from another member of the audience. So is this real-time automation only useful for industrial verticals, or is it applicable for verticals such as smart cities? Do you think it's got a wide range of applicability?
I'll let you go first, Ravi, because I don't want to be that guy.
No, you're fine. I think both of us like have the answers in our like the tip of our lips, right? Yes, absolutely. It is applicable to all industries where real-time information is necessary, right? Industrial automation, simply because it's very complex. So we tend to kind of like get involved a lot more in that space. But yes, absolutely. Smart cities, different aspects of smart cities, like smart traffic lights, for example, or other aspects like connected cars, for example, needs real-time information to make sure that the experience that you provided, the in-vehicle experience is like superlative, right? So transportation and logistics, absolutely important, right? If I have like this, I have like 100 orders that I need to fulfill, I need to make sure that I have all the right information, and real-time information is absolutely important for that, and good quality information. You don't want to deliver the package in the wrong address. Yeah, go ahead, Dheeraj.
So that was my point of view as well. Like, and it's not even just sensor driven, right? Like, so because it could be just the user interaction driven. Like, to think of the likes of videos on demand kind of platforms, or you think of a gaming system. Like one of our customers is actually a baccarat table, right? So the table is not. The table makers are our customers. Like, the table is fully connected with the chips, the cards shuffling, the shoot well, and everything is connected with the player card. And it's basically like being able to pay out the perfect amount for every hand. And so the dealer is never making a mistake. So I'm just giving you like how obscure a scenario could be that requires real time, right? So when you look at real time, things that need to be accurate, fast, and done in extremely low latency, perhaps at scale even, all of these need to come together, and suddenly like your real-time definition changes from like, oh, like there's a bunch of data, I ask a question and I want an answer in real time, but it doesn't matter how old the data is, right? So two, a world where the freshness of the data immediacy, as one of my colleagues actually refers to it, and I would actually even augment to that, like data immediacy and decision immediacy. Those two come together, bang, that's your new real-time definition, basically. So.
Great. And we've probably got time for just one or two more questions. So I've got another one from our audience. Are there any sort of performance requirements from a network perspective that supports low latency in transport or of real-time data between edge to cloud?
Yeah,
it's all you.
Oh, it's all me. Okay, I'll take that first. And yeah, so MQTT is kind of like that's the bedrock of MQTT, right? So a quick story around that. It started in oil and gas in the late 90s. So a couple of people from IBM, in fact, one of them is with me here, called Alan Nipper, at this conference that I'm in this week in Folsom. He's the co-inventor of MQTT from IBM for Phillips 66, because they have remote assets in the middle of nowhere, oil wells that need to be connected, so you can do monitoring for safety purposes as well as just reducing costs. And the biggest issue was that, first of all, the bandwidth was very, very limited and connectivity was very poor. So MQTT started as a publish subscribe based protocol because you wanted to address that. Whatever limited bandwidth, limited connectivity, latency requirements you had, you wanted to overcome that by trying to post information in an asynchronous fashion to a centralized broker. And then the broker can then share that information asynchronously with other clients that need that information. So it's much, much more efficient. Even in low latency or low bandwidth and low connectivity situations, it works pretty good. So that's one option, but there are other things, like there are store forward options that you see on edge solutions, other ways you can kind of reduce the latency as well that I've encountered.
Great. Darius, anything to add on that?
Yeah, I mean, I think this is an interesting space, right? And latency, especially between edge and cloud, is quite a hot topic. And the move towards things at the edge to try and reduce latency becomes quite big, and moving things even more distributed to on device edge. But that connection between edge and cloud is still pivotal and still vitally important. And I think that does come down a little bit to what kind of infrastructure the telco builds out. What kind of what hundreds of Gs of transport network are they going to implement to come out to some of these sites, right? And even when you move further and further in the network, and we move towards not just edge to cloud but edge to edge node, I think that becomes extremely important, especially in the context of smart city. So I think there are still some big questions there as to what kind of transport networks do they build out, what kind of infrastructure do they have. But I think it's something that is being looked at by those operators and those that have been a little bit more bullish around rollout of the network edge specifically. I know they've been looking at what kind of latency and jitter do they get between edge and core data center or edge node and edge node. But it is harder, especially as you start to go across different telco networks. So smart city won't be just a one telco network solution. So as well as edge to cloud and edge to edge, you've got to think. Let's take the UK BT Edge to Vodafone Edge. That becomes another point of latency. So, smart people like Ravi and Dheeraj, I think, will hopefully be the ones helping address some of those issues.
I actually, what you both said, spurred some of the thoughts that we're actually working with a video management software company, and in fact, Hive is also introduced. The three of us are joining hands to do something amazing, actually. So
awesome,
in the near future. So we're not going to spill the beans here, I suppose. But but what's really interesting is as the video quality is increasing, right? So it's it's going from 1080p to 4K to 8K. And is it just because it's clarity? So the clarity is actually a huge difference in being able to programmatically identify anomalous things in that frame that you're actually looking at, right? So how fast can you actually convert that frame of video into data? Do you need to send the entire frame into the cloud for looking at it? That's where your bandwidth starts actually taking a hit, right? So an 8K video over bandwidth is going to just clog it up. It's just not going to get there in time for you to make a decision. So we see a lot of these camera players bring in the intelligence to the edge, and one of the core values of Hive and Volt working together is should you start worrying about the bandwidth and start doing more things at the edge? So you're using the bandwidth from edge to cloud wisely and more efficiently. So you're only sending what's required and necessary to the cloud, right? So
yeah,
bring that
that's
processing intelligence to the edge and just look at so one of the things that I'm thinking will happen is like raw data is not going to be used for machine learning in the near future. It's going to be meta learning, right? So if you only send the exceptional behavior data, but then the previous learnings are there, and then you use the exceptional behavior to just delta train rather than just completely retrain, so to speak. So I don't know, I'm just coining words at random here, but like we'll see like what happens in the future.
yeah, it will become words for the future. It will become trends for the future, Dheeraj.
Delta training. There you go. You heard it here first. Right.
Oh, there you go.
Right. Thank you very much. That's all we've got time for today, sadly. So any questions that weren't addressed during our panel, we will get back to you offline. Just want to say another thank you to our presenters, Ravi, Dheeraj, to Darius for supporting on the panel, and just a final reminder that the recording and slides will be shared with you. And if you have any questions, please feel free to reach out to myself, Darius, and we'll see you next time. Thank you.
Thank you.
All right.
Bye-bye.
It's been a pleasure. Cheers.
Cheers.
Thank you.
Cheers. Bye.